Hello everyone, in this video, step 6, step B, we will show how can we use Matlab to transfer a process model from S domain to a Z domain discrete equation. A process model with a S domain could come from the engineering team or research team, or you can use the record data and identification toolbox from Matlab to identify the process model by using the first order and the second order process model. I also used one video before to show how can we record the process data and how we can use the record data input into the identification toolbox, the tool from the Matlab, and how we can identify the process model. In that video, I showed using my data to identify a process that is a second order process transfer function. And in this video, we will use the Matlab to transfer a process model from the S domain to a Z domain. After this transfer, we can input this Z domain process model into the Matlab Simulink. And because the Z domain transfer function is easy to implement in the computer system, after we get this Z domain transfer function, we can import this Z domain transfer function inside the Matlab Simulink and run this process model as a simulated process model. And we will use the PID inside the PLC control this process model. We will discuss this in the following videos. So in this video, we will mainly talk about how can we transfer a process model from S domain to Z domain. Alright, let's go to the Matlab. And the Matlab, what I'm using, that is R2018b, this version. Okay, so firstly, you need to define the one directory. And from this directory, I will build up one new script. That is a .m file. And then I will save this file under our directory here. Okay, so I will name this .m, name as a process Z model for Simulink. Okay, click the save. So firstly, I will write a comments here. We have a one reference second order transfer function. Okay, this is our reference transfer function. That is one second order overdamping system. So the gain of this transfer function, that is a minus. That's because this transfer function was identified from one cooling system. This is from actual process. To identify this transfer function, the sample time, that is 0.5 seconds. And the tool to identify this process, that is a identification toolbox from the Matlab. To build up this transfer function, we will name K0 equal to T01. Next, that is a T02. So this is our reference transfer function here. But currently, this style of the transfer function is not the pull and the zero transfer function style. So we need to calculate a little bit, transfer another style as a pull and a zero style of the S domain transfer function. So let me calculate a little bit. So we can see the gain. So the KP P1 and the pull, the first pull, that is a 1 over T01. Okay, the second pull, that is a T02. So to build up one transfer function, the pull and the zero style, we will name NUM G1. This is the first sub-transfer function, okay? And the NUM2, the pull 2, okay? So this is the first one, and this is the second one, okay? So our G1, that is equal to transfer function NUM and the G2 equal to transfer function okay. So the final system transfer function ice domain, that is equal to the KP time the G1 and the time G2. So till here, let's run this process and verify if this final system transfer function is equal to this, the target transfer function. So after this conversion with this pull and the 0 style, we transfer this system transfer function as this style. And we can run the step response. Let's look at the step response of this transfer function. Okay, so let's run the step response. From this step response chart, we can see the behavior of this process model. So that means if we give a step response, give a 1 into this system, so the feedback will decrease 0.3, around 0.3. That can represent the temperature. And this response time basically is greater than 100 seconds. So that is a temperature that is a slow system. And this is a S domain transfer function. We need to transfer this S domain to a Z domain. But before we transfer to Z domain, we must define what the sample time we need to convert to a Z domain. So this TS sample time, that is 0.5 seconds. Okay, and then to convert to a Z domain, we can call this system transfer function Z domain equal to C to D. Convert the S domain to a Z domain. System transfer, and that is a TS. We will add a 0 holder here. And the TS here, we will name this TS 0.5 seconds. This model will be used in this Simulink here. Okay, so let's run temporarily. And let's see what the transfer function under the Z domain. Okay, with 0.5 seconds, this is sample time. So the Z domain transfer function is like this. Alright, we finished the first step. We build up this transfer function from a process model that is a second order overdamping system, that is a temperature cooling system. And this MATLAB script can be used as a template. As we can see, it can transfer a S domain process transfer function from S domain, that is the pull and 0 style, and transfer it to a Z domain with a sample time setting. After we have this discrete transfer function, so when we use the Matlab Simulink, we can type in or import this transfer into this area, and let this Matlab Simulink run this transfer function as a simulated process. Alright, in next video, I will show how can we use the Matlab Simulink to type in this process model. How can we set up this control loop in the Matlab Simulink. See you in next video. Thank you for watching. If you like this video, please give me a thumb up If you'd like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.